Okay, so like I said, today I just still go over for the decimal, the decibel. The thing is, last time we forgot to record it. So quickly go through it. Okay. So basically, if you want to be a technician, then you have to get a knowledge. Anything related into the electronic. On the lecture, we try to get only thing what you need to know, not go into too many details. Okay? So basically, you have to understand when we get through it. Okay? So try to download the handout for the decibel and go over. Okay? Have to be go over, and over too many times. Hopefully you can understand. Okay? The decibel unit is important in amplify measurement. Okay? The decibel is a measurement of ratio. Okay? The ratio of the one power to another. That means the ratio between the P out divided to P in. And the voltage will be V out divided V in. And the current will be I out over I in. Okay? However, they want to display in decibel. If they get in decibel, you're able to converting back to normal. Okay? The reason is in the company, they get the lab that for RF radio frequency. Okay? In the radio frequency, they measure they using the dB. However, we have to convert it back into normal. Okay? So this is the formula. Power gain, if you want in dB, this is the formula. Voltage gain, AV. You understand the A means the gain, P means the power, AV means voltage gain. Okay? And if you see the current gain, AI, okay, will be AI 0 dB reference. What that means? Maximum gain. That we call a mid-range and will be 0 dB value. And now the next one will be a critical frequency. They asking for you have to understand what for critical frequency. Okay? This is also they can be a cutoff frequency or corner frequency or break frequency. That will be called critical frequency. Okay? So what happened? At that frequency, the power drop one half, okay, of its mid-range. That means at the critical frequency, power AP will drop 3 dB, minus 3 dB. And also, at the critical frequency, output voltage is 70.7% of its mid-range. That means AV for dB also drop minus 3 dB. dBm, power measurement, a unit that often measures power in the dBm. That means they're talking about unit in dB. dBm measure that was reference to 1 milliwatt of power. That's the definition. Okay, and this is the formula to calculate the dBm. They equal 10 times log of power divided 1 milliwatt. That means you want to converting from dB, okay, to get into the dBm. That is the formula. And we already get the formula. For example, 30 dBm, okay, equal how many watt? That will be telling you one thing. In the lab, they measure. They're using unit dBm. However, we have to deal with the watt or milliwatt or kilowatt. Okay? So you see how they do it. They say dBm equal the formula. That formula they just give it to you. 10 times log of P divide 1 milliwatt, and they given you 30 dBm. Okay? So they will be get the 30 divide 10. Okay? And you get 3. That's the log of P over 1 milliwatt. Okay? Equal, you take 30 divide 10. Okay? That's why you get number 3. Okay? That's telling you they take the log only. So that's why equal 30, you divide by 10 here. You get a 3. And now they don't want the log anymore. They say anti-log. That means you remove the log. You can get 1 mil P over 1 milliwatt here. Okay? Right here. Equal 30 divided by 10. Okay? 3. And you want the no log anymore. Okay? they will be equal 10 to the power of 3. You get 1,000. Okay? 10 power of 3. You get 1,000. That will be telling you P equal 1 milliwatt times 1,000. You can get 1,000 milliwatt or 1 watt. Okay? That will be telling you if you get dBm, you're able to converting to milliwatt, kilowatt, or megawatt. And the next, they want to adding 1 dBm to 1 dBm. Okay? What you have to do, you cannot adding dBm. Okay? They have to converting back to the watt or milliwatt, adding it, then you have to convert it back to the dBm. That's what everything will be in here. Okay? You get the time. You have to go through it to make sure you can get what we want. Okay? They say the note in here cannot adding dB watt to dB watt or dB volt to dB volt. Okay? That means dBm adding to dBm, you cannot. dB volt to dB volt, you cannot. You can dB watt to dB watt, you cannot. You have to converting to milliwatt or kilowatt, and you add them up, then you have to converting back into the dB watt or dBm or dB volt. Okay? And they given you dB watt, the formula. This is the formula for dB watt. This is the formula for dB volt. Okay? That means you want to converting watt to dB watt to watt or dB volt to volt. You have to using that formula. Okay? And this is example. Okay? What they say, a data sheet say that output amplify 24. Okay? dBm. What is the output power? Now, you can see the solution. dBm equal, this is the formula, 10 times log of P1 over milliwatt. And that equal 24 dBm. And now you want to take the log only. That means you take the 24 divide 10. Right here, 10. Okay? And you take the log out. So P over 1 milliwatt equal 10 power of 2.4. Okay? And that given to you 251.2 milliwatt. Okay? And you can try your related problem. Same thing. Okay, now you get a one gain, another gain, and they can get a more gain, okay, in the system. So they telling you one thing. If the gain in normally, you take the first one here, AV1, times AV2. And if you get more, times AV3. However, if you're talking about the gain dB, then you cannot multiply. They add them up. AV1 dB, adding AV2 dB, and adding dB3 so far. Okay? That's just a basic formula. Impedance matching on resistance should the same. RG equal R in. That means the input here, output here. Okay? Should be the same. R in equal R out equal RL. Okay? Equal R. Impedance R in microwave system 50 ohm. R in TV 75 ohm. Coax cable or 300 ohm twin lead. Impedance R in telephone system 600 ohm. Okay. At the hyper-frequency microwave, dB watt is the usually unit yield when the reference at 0 dB watt equal 1 watt, dB volt equal 1 volt. And this is a formula. Okay. Relation between dB watt equal 10 times log of the P over 1 watt and dB volt equal 20 times log V over 1 volt. So basically, that's the same formula like dBm. Okay? And they given you the example here, power gain. Okay? You get a 2 watt here input and you get a 200 watt output. Okay? So power gain in dB 10 times log of 200 watt divide 2 watt. Okay? You get 20 dB. Okay? Output power dBm. Okay? Equal 10 times log 200 watt divide 1 milliwatt. You get 53 dBm. Okay? Output power dB watt equal 10 times log of 200 watt divide to 1 watt. Okay? You get 23 dB watt. So, the input power P in equal V in square divided to R. And the output power P out equal V out square divided R. Okay? Just a formula. And this one here, just a review. Okay? You get the time. You try to see you can do or no. Okay? And it also just a review. Okay? For example, number 10, they get 27 dBm equal to how many watt? Okay? Then you have to using the formula. Okay? dBm equal okay, it's just a 10 time log. Okay, of P again divide 1 milliwatt. Okay, so they will be 10 time log of 20 that equal 27. dBm. And now you want log only. P 1 milliwatt equal 27 divide 10 equal 2.7 anti-log. So you want only P, okay, over 1 milliwatt equal 10 power 2.7, okay, equal whatever number. And now you can get P equal 1 milliwatt times that number. Same thing. Add 0 dB volt to 0 dB volt. You cannot add dB.
I have a question.
Then you have to yeah.
Can I ask my question real quick? So in terms of a technician, can you go back up real quick just so I understand this? Um, okay, could you scroll up real quick, please, just so I could look at the previous slide?
The previous one. Oh,
Yeah.
what?
So as a technician, will I be using this same math while I'm, touching the circuit board? Or well, I'll be doing this on the lab vault, right?
No, nothing on level. That what
There's
I,
no lab vault on this?
no. They're using the dB, but they're not, working on that. I can telling you, normally the company, they using nothing with the dB or dBm. Only thing is you get into the RF lab, radio frequency lab, then they using dB, dBm. So when you measure it, you get the value will be in dB. And they want to know what equivalent for what kilowatt, okay? Then you have to convert it. Outside
Okay,
that
so things
lab,
with audio.
yeah, outside that lab,
Okay.
you do nothing with dB. However, I can tell you, if you can get into IF lab and you can do it, guarantee the job will be very stable. Most of the students in the past, they are working on defense company. In any company in electronics, they have to get a lab working for radio frequency. That means the signal transmitted over the air. Okay? But in this one, basically, technician, you don't have a chance to working on dBm. Okay?
Okay.
That's
I
not
got it.
regular technician. But if you go to the engineer, then you will be learned.
Okay, thank you.
Yeah, no problem. Anything. Okay? And now I want to talking about the last one here. Okay, you get 10 dB here and lot 3 dB, 10 dB, lot and out. You get in. Okay? For the circuit so output equal. Okay? So let's see. 10 dB, you lot 3, you get 7 dB. adding to that 10. That means 17. Lot here. And you adding a 7 1. Okay. Last time I already telling you what the answer. If you've been here last time meeting, so what the answer A, B, C, D?
D, I would think, because you said you keep saying you can't add them.
Okay, I just asking you A and B or C or D, telling me which one. That just have
I'm guessing D.
for the people, for the student not here last time. We don't have a recorded, so that's why we will have them. Mr. Smith telling me which one, A or B or C or D.
Okay, the way I understand it is starting off at the front is 10 minus 3, which is 7 left over. Added to 10 is 17. And I don't know what you do with the 17. And then,
Lot 3, right?
okay, 17. Do you add that or subtract that?
Now do lot 3. 17 here, right?
Right,
Now do lot 3, you get 14, right?
14 and 10 is 24.
Okay, you get 24.
But
However,
so
yeah,
it would be none of them then, because
right.
I thought you go.
No, no,
Let's do this real quick, Mr. Pham.
I
10,
understand. I telling you the mistake here. What the in? They have to telling you in here equal what? Okay, I will be update that. If they given you a 10 dB here, so 10 dB here, right? So input is 10 dB, okay, and you get a 1020 minus 3,
which is 17,
yeah, 27.
and 10 is 27.
And now you increase 10, 37, right?
Okay,
And you log 3, okay,
that would be 34.
34, and you can add in here. So basically, I need to looking into the in here, not the 30, not the 10 dB. Okay, we'll
So
connect that.
so what is the answer then?
No,
C.
no, we have to get the input in dB.
Yeah, but what is the answer?
I don't know. I have to looking over that to see in equal how many dB.
Yeah, but just based on what you're saying, or you knowing what the correction is it 10 minus 3, which is 7, which is 17, and because you add the 10 to it, and then if you add another 10, it's 27,
And you get the 3.
and you got so with that 3, do you subtract it?
Yes,
Okay,
24.
20, then it's 24 then.
And you get 10, 34, right? Okay, so I will be correct.
Okay, you make the correction.
Yeah, for the circuit, so the output equal, but they're not giving you the input. Okay,
All right.
we'll check that. Okay, now we're talking about differential amplifier. Okay, a differential amplifier, yeah, bipolar junction transistor amplifier that produce output that are function of the difference between two input voltage. Okay, when you're looking into this circuitry, okay, make sure you know this is a name will be differential amplifier. They get the two input one and input two. Also, you get the two output one, output two. That's what they name is a differential amplifier. Okay, in order to understand differential amplifier, okay, they get Q1 and they get Q2. Then you have to know for Q1 what the configuration. You understand we already studied bipolar amplifier. They get the first one will be CE amplifier. Next will be C amplifier. And the last will be CB amplifier. That's the first thing. I don't know you know how to calculate or not, we don't care. But you have to recognize by looking into the circuitry, identify the CE or CC or CB amplifier. That's the first thing. Second thing, the relation between the input and the output for each amplifier. So now I'm talking about Q1 first. Here. So for Q1, what the amplifier? Which one?
Q1, you got an output coming from the collector, so that means it's a common emitter.
Okay, correct. That means the first thing I know, Q1 in this case, they will be CE amplifier. The thing is, if you're looking back into the CE amplifier in the bipolar, so CE amplifier input apply to the base, output from collector. Okay? And you're looking input sideways here, and the output sideways, however, opposite, 180 degrees of phase. That's a basically minimum thing you have to memorize. Okay? If you get a question, just go ahead. I will help you. Okay? In order to know amplify CE or CC or CB, that means you have to go over on those amplifier. Okay. Now, when you get the input sideways, okay, go in here. So at the meter, also you get the sideways. Same thing. Okay. No bypass capacitor, nothing. So you still get sideways. And now you're telling me what kills your amplifier?
And Mr. Pham, you told us last time, I think I know the answer, but my point is I don't know, I don't see it like is the way you do, but you told us last time it was common base.
Common base.
Hey, Mr. Pham, if you could just show us how is that the way it's hooked up? How is it common base?
Now telling me you have to remember one thing. When you want to telling the amplify common emitter, common collector, common base, you need to identify input is go to where, output coming out from where. That will be telling you. Okay?
Okay.
The thing if you go to read for the CBMD5 and you know the input go to the emitter and output going out from collector. Okay?
Mm-hmm.
And input sideways, output sideways in phase. Before you want to go a differential amplifier minimum thing, that's what you have to understand. You don't have to memorize on the formula, whatever, who don't care. This is a general, basic.
Yeah,
So
but
if question,
Yeah,
so if input one and output one were on the right side, and output two and input two and output two were on the left side, would the right be common emitter and the left side be common base?
exactly.
Okay.
Why I say common base? You open the common base, you can see input go to the emitter, output from the collector. That's why I say common base. Second thing, input and the output will be in phase. That's the only thing you must know. You interview for the technician. They just asking you in general to see your knowledge. They're not asking you the formula. They're asking you about understanding. The thing is, I've been in the company for too many years. I interview a lot of technicians. Okay? That's what normally we asking. Okay? Now, so this is the symbol for the differential amplifier. Input 1, input 2, output 1, output 2. This circuitry basically inside that one. The thing is basically you cannot see this circuit. They draw that one. Okay? Not in the detail. Now to see in here what they telling you. Assume both transistors identical. Everything will be the same. RC1, RC2, same thing. IE1, IE2. This is the IE1. Here. This is the IE2 here. Okay. Equal IRE. That means the current goes through RE divided by 2. The thing is this go here, this go here. Okay, same thing. Okay, and VC1 equal VC2. Okay, this is a VC1 here, VC2 here. Okay, equal VCC minus IC1 times RC1, and VE, VB equal VB minus 0.7. That's a normal. Okay. Now, if you see this thing here, this one they rounded. This one they rounded. That means Q1 and Q2. Okay, they round the base. And they using the meter. You measure the output of Q1. This telling you the voltage here. And they measure the output Q2. Same thing voltage here. You see that? Same thing. Okay. If both input will be the round. So whatever voltage here and the voltage here will be the same. Now, next one. They connect B1 and they round it on the other side. Q2. Okay. For this configuration, sideways connect to here, VB1. Okay. And the Q2 they rounded. So what they said, Q1 ECE amplifier. Okay. Input and output Q1 inverter. Okay. They're telling you get a sideways here, that you get a sideways here. They will be 180 degrees out of phase. Okay. For this configuration, VB2 is round. Q2 is CB amplified. Input output Q2 is in phase. That means whatever here output here will be sideways or sideways here, they will be in phase. Okay? That's what they try to explain to you. And now what happened here? Okay. For this configuration, sideways connect to VB2. Okay. So now they rounded that guy. They connect into Q2. Okay. And now Q2 will be CE amplified. Okay. Input output Q2 inverted. Okay. They will be opposite. Okay. For this configuration, VB1 is rounded. So Q1 now will be common base. Okay, Q1 is CB amplified. Input, output will be in phase. Okay, that's what they try to explain to you. Now, they've given you a little more thing with a more picture here. First thing is they apply sideways to Q1. So input is a sideways. Output a sideways, and you can see they will be 180 degrees out of phase. They will be a CE amplifier. And this sideways go into here. Sideways input, and Q2 will be a CB. Okay? CB, so the input output will be in phase. You can see output here. They will be in phase. This one they draw a really signal. Okay? For you to looking into that. Okay? In this case, we all again Q1 will be CEMD5. Okay? Input, output opposite. Q2 will be CBMD5. Input, output here, input, output will be in phase. That they want you to know. Okay, this is just the opposite, right? Now they apply here from Q1. So Q1 now will be CB in phase. Q2 now will be inverting. So that's why they opposite. Okay? Okay, now they're using the symbol, not draw the circuit anymore. So input one, they apply sideways. Okay? And they're telling you, okay, first one output Q1, they sideways, but they opposite, inverted. Okay? And output 2, they will be CBMD5. They will be in phase. See that? Up, that up, down, they go down. Okay? And if they apply input to Q2, then you can see they can get output here and output here. They will be opposite. Okay? Differential input to opposite polarity out of phase. Signal are applied to the input. So now if they want to apply input for Q1, input for Q2, one thing you must be know, these two input, they must be opposite. Okay? If this go up, this have to be going down. This going down, this have to be going up. They must be opposite. Okay? And they
What
give
happens if
you
it's the
output
same
here.
thing?
One here. Yeah. Question.
What happens if it's the same thing? What if both of them are the same way? It's
Yeah.
like something going to blow up.
I know. No. We'll see. Right now, they're telling you, if you want to apply signal into differential amplifier, input one, input two, they must be opposite in phase. And you can get the output coming out. 1, 2, they opposite. Now, that's what they're talking about this part here. Common mode input. Now you see they get same thing. Go up, go up, go down, go down. That they're talking about common mode. We see both input are the same phase, same frequency, same amplitude are applied to the two inputs. The output are superimposed and they are cancelled out. See that? Resulting in zero output voltage. That means if you apply identical sine wave, same phase, that will be telling you output will be zero. This action equal a common mode rejection. Okay? Common mode rejection means that this unwanted, that means the noise signal will not appear on the output, the desired signal. Common mode signal, that means the noise, generally are result of the pickup of radiated energy on the input line from adjacent time. Okay, now what that means? That means if you get the input of the op-amp, get the same signal, the same everything, that's what we consider to be the noise. Okay? That means the radiated from the power is coming out. That means the unwanted signal. They will be affect to input one, input two. When the op-amp looking back, they see the same identical signal. They consider that be the noise. And they want to cancel out. That means the output will be zero. Okay? So that's why normally when they try to apply input into differential amplifier, they must be opposite. Okay? If they're the same, they will be considered to be unwanted signal. Unwanted signal, that means the noise. They cancel out. Okay? Common mode rejection ratio, they call it CMRR. The formula CMRR equal AV D. AV means the gain, voltage gain, different voltage gain. D means different. Divide ACM. Okay, they try to explain to you here. AVD, difference on voltage gain. ACM, common mode gain. Okay, that means the noise. The higher the CMRR must be better. Okay, the CMRR common mode rejection. That means the equal the ratio between the gain and the noise. Okay, the CMRR often expressed in dB as the formula here. CMRR dB equal 1020 time log of AVD. That means the gain divided ACM. That means common mode. Okay, just the formula. Okay, example. A different amplifier has a different voltage gain, 2000, and the common mode gain, 0.2. They want to know CMRR. So, CMRR AVD divide ACM. That means you take 2000 divide 0.2. you get 10,000. And now, if you want in dB, then you have to know the formula. There's a dB. 20 times log of 10,000, you get 80 dB. Okay? Now, what I want you, go ahead and try to do on the B. I want to know the answer. Okay? CMRR.
90.629.
CMRR. Okay. AVD. And CMRR. Okay, telling me what first one, CMRR. That's a
34,000.
what?
34,000.
4,000. That one answer 4,000
34,000.
or 34,000. Sorry. How about DB?
$90.629.
What number?
90.6.
90.6 dB, right? Okay, who can get the same answer? Who else? I have to get someone else get the same answer.
Yes, I got 90.6 dB.
You get minus?
No,
No.
I got 90.6 dB.
Okay, so you get the right one with the other guy.
Yes.
So this is the right answer.
I have a question.
Yeah, go ahead.
Earlier, the previous slide before this one, it said that the higher the CMRR, the better. What values are we looking at? What is considered a low value for CMRR and what's considered high?
Okay, let's see in here, right? Somewhere in here.
Correct. It's the second, well, it'd be the third bullet.
Okay, higher CMRR, better. That
Yeah, so what
means
is it?
this number higher than
Higher
better.
than what?
If you calculate the small number, that's not better. Instead, you can calculate they coming out with 50.6, for example. That means the number is smaller. That is not good. The number they need as big as we can. อันนี้ they number CMR in dB. They want that number as big as, they can go. When you calculate two things and you come one CMRR equal 90.6 and another one CMRR equal 50.5. So the 90.6 will be better. That's what they try to explain to you. Okay, this is the example. If you're looking on the circuit and you know this is a differential amplifier, okay? However, this is the input one, input two. They're using only one output, okay? They want only one, not two. So for the differential amplifier circuit, so they say single-ended output. That means they're supposed to get two output, but they're using only one. They given you AV, the gain, 2,500, and common mode rejection 30,000. Okay, V in 1, 500 micro VIMS. That means right here, input here. Okay. At the same time, 1 volt 60 hertz. Common mode interference signal appear. That means same time you get a sideways here, sideways here. They go to both input 1 and 2. 1 volt 60 hertz. Okay. They want to know, they determine the common mode gain, ACM. Express CMRR in dB. Determine the IMS output. Okay, now try to see how they explain to you. First thing, CMRR equal AVD equal divide ACM. That will be calculate ACM equal AVD divide CMRR. That means they want to know ACM. Okay. AVD equal 2500 divide 30,000. You get 0.083. Okay. And now they want in dB. Okay. Then you take the 20 log of 30,000. Okay. And that will be given to you 89 dB, 0.5. Okay. Number C. Output IMF V in different equal V in 1 minus V in 2. V in 1 here, but we don't have any V in 2. So that's why they minus 0. You get 500 microvolt. Okay. V out equal AVD times V in. That means the gain 2500 times 500, that's this guy here. You get 1.25 VIMS. Okay, that's very simple. Another example. Okay, now you can see this example different from the other one. Only thing they apply input 1 and they apply input 2. That's a difference. Okay, and if you're looking into here, input 1, input 2 will be opposite. Okay, different phase all the time. So for differential amplifier, so single-ended, that means only one output. Every day, CMR V in 1 equal V in 2, 500 microvolt IMS. At the same time, 1 volt 60 hertz will be here. 1 volt 60 hertz. That consider to be the noise. Okay. The thing is, the radiator from the source coming out, they affect you both. Okay. And the calculation will be the same. Solution. V in different equal V in 1 minus V in 2. Okay. V in 1 will be the same. Okay. 500. And they must be opposite. So that's why 500 minus to minus 500. You get 1 millivolt IMS. Okay. V out equal AVD time V in differential. That means 2500 times 1 millivolt IMS, you get 2.5. Okay. ACM equal V out divide V in CM. Okay. And let's see. ACM time V in CM. Okay. They will be a 1 volt. Okay. So that's why 1 volt here. Okay. And 0.083. Where is that number? They take ACM time V in. Okay. ACM. V in CM.
Sorry, one more question.
Yeah.
If it's a single-ended output, do we have to worry about V1 and V2 being in phase?
V1 and V2, right?
Well,
You're talking
do we have
about
to worry about
you're talking
Go
about
ahead, sorry.
you're talking about that one, right?
Either? I don't know. I
V1
just wanted
and
to
that
know if
one.
they have to be in phase.
No, cannot.
Okay.
Remember one thing. Input signal must be opposite. If they will be in phase, they consider to be noise. This guy. Okay.
Okay, got it. Thank you.
Yeah. In here, V in CM, 1 volt. Okay. And ACM, if the calculate the ACM, let's see. Here, that is the ACM. Okay. That means you need to calculate ACM. AV divide CMRR 0.083. So that's why in here they given you 0.1083. Okay. Okay. That will be N for differential amplifier. Differential amplifier. Okay. Let's see. Next meeting will be that one here. Okay. That means next meeting we'll be talking about operational amplifier. Okay. That means next one. Now, I recommend the guy. Okay. You have to go to the Canvas, download the assignment. Okay. And try to do it. Then you have to be uploaded. Okay. For assignment. And if you want to watch the recorded, then you can go into the video, okay, and you can see. I try to make, you get a take one and take two. I try to make both take one and take two also display same thing. If take one, you're working on take one, or you see on take one. If you on take two, you still want to looking into video or hand out everything from take one. You can go to take two. You will be see the same, but you don't have to do if you already uploaded, if you already get it done. Okay? You see now they can it. It's controlled by SDCCD. And the program will be changing. I'm telling you later on what the program supposed to be look like. Okay? At this time, AC meter you can get 22 file. Okay? That means 250 hour. So one thing complete one semester you get 250 hours only. And you understand this program at the beginning. We get a take one, you have to get 450 hours. And take two, 450 hours. Total will be 900 hours to get a complete certificate. However, I don't know. How come they can only 25, 250 hours for one semester? And also, we still get another thing we have to learn. That means for AC circuitry. Right now, what you done? You done for DC. You done for electronic. But it's not the AC. Okay? So that's why we will get the I try to working on in order to modify the way the program running. Okay. And also you see, last 2 years, no summer. So basically, you get the first semester 250, second semester you get a 250. So 2 semesters you get only 500 hours. Cannot to be a technician. Okay? So I will be trying to modify that and will be let you guys know. Okay? So we want you guys to be a technician. And also, I will be also working on when you do the left vote, what you supposed to go to do first. Second thing, I already up there and I saw the people try to sit down and they call writing down the note, whatever. I don't care. When you do a left phone, you just do it. We don't have enough time. The left phone program, if you want to complete that, like in the past, they asking you 2 years. Okay? That's too many things. And now that's a new, that's a basically different time. So that cannot be applied everything. We just want you to do the lab. And if you want to see it again, I will be giving you the way you can copy, save to PowerPoint. Later on, you get a time you want to look over and you can open your PowerPoint. You can see. Now you get only Monday, Tuesday, Wednesday, only 3 days a week to do the lab. No way you can get through it. Okay? So that will be talked later. Now, any question? So normally I will be start the Zoom around 5:10. Okay? And basically 1 hour, but now also over 1 hour. Any more question? Anything? Okay? Anything? No question.
No.
This time, you guys coming to the Zoom better than in the past. I hope. Okay? Everyone have to be get into the Zoom. So, if no question, nothing. Okay? So I wish all of you get a very good weekend. Okay? And we'll see you on Monday.
Okay, thank you.
Okay. Bye-bye.
Thank you, Mr.
Thank
Frank.
you.
Mhm.
All right, bye.
Bye-bye.